Confusion matrix in model evaluation. AI beginner level. Introduction. When evaluating machine learning classification models, it is important to understand how predictions are correct or incorrect. One of the most useful tools for analyzing model predictions is the confusion matrix. A confusion matrix provides a detailed breakdown of prediction results, showing where the model performs well and where it makes mistakes. Confusion matrices are widely used in AI applications such as spam detection, fraud detection, disease diagnosis, image recognition, sentiment analysis. Understanding the confusion matrix helps developers analyze model performance more clearly than using accuracy alone. What is a confusion matrix? A confusion matrix is a table used to evaluate the performance of a classification model by comparing actual values with predicted values. In simple words, confusion matrix equals table showing correct and incorrect predictions. Example concept: actual values versus predicted values means confusion matrix. This table helps understand different types of prediction outcomes. Structure of a confusion matrix. A confusion matrix for binary classification contains 4 possible outcomes: actual, predicted, positive, negative, positive, true, positive, TP, false, negative, FN, negative, false, positive, FP, true, negative, TN. Each of these represents a specific prediction result. True positive, TP. True positive occurs when the model correctly predicts a positive case. Example: a fraud detection system correctly identifies a fraudulent transaction. Example concept: actual positive means predicted positive. True negative, TN. True negative occurs when the model correctly predicts a negative case. Example: a legitimate transaction correctly identified as legitimate. Example concept: actual negative means predicted negative. False positive, FP. False positive occurs when the model incorrectly predicts a positive case. Example: a legitimate email incorrectly classified as spam. Example concept: actual negative means predicted positive. This type of error is also called a type 1 error. False negative, FN. False negative occurs when the model incorrectly predicts a negative case. Example: a fraud transaction incorrectly classified as legitimate. Example concept: actual positive means predicted negative. This type of error is called a type 2 error. Example confusion matrix. Suppose a model predicts whether emails are spam. Actual, predicted spam, not spam. Spam 4010. Not spam 545. Example concept: prediction results means confusion matrix table. From this table we can calculate TP equals 40, FN equals 10, FP equals 5, TN equals 45. Why confusion matrix is important? The confusion matrix helps developers understand how the model makes mistakes. Benefits include: shows types of errors, helps calculate evaluation metrics, helps improve machine learning models. Example concept: prediction errors means confusion matrix means model improvement. Metrics derived from confusion matrix. Several important evaluation metrics are calculated using the confusion matrix. Examples include accuracy, precision, recall, F1 score. Example concept: confusion matrix values means evaluation metrics. These metrics help evaluate different aspects of model performance. Example Python code. Example confusion matrix using Python. From sklearn. Metrics import confusion underscore matrix. CM equals confusion underscore matrix. Y underscore true. Y underscore print. CM. Machine learning libraries such as scikit-learn provide tools for generating confusion matrices easily. Confusion matrix visualization. Confusion matrices are often displayed as heat maps or charts to visualize prediction results. Example concept. Prediction results means confusion matrix heat map. Visualization helps data scientists quickly identify model strengths and weaknesses. Real-world applications. Confusion matrices are used in many AI systems. Healthcare. Evaluating disease detection models. Fraud detection. Analyzing detection accuracy of fraudulent transactions. Email spam filters. Measuring spam detection performance. Autonomous vehicles. Evaluating object recognition models. Concepts learned from confusion matrix. Understanding confusion matrices helps beginners learn. Checkmark how machine learning models make prediction errors. Checkmark how classification results are analyzed. Checkmark how evaluation metrics are calculated. Confusion matrices are one of the most important tools for model evaluation in AI. Simple definition. Confusion matrix. A table used in machine learning to evaluate classification models by comparing predicted values with actual values. Final summary. A confusion matrix is a powerful tool used to analyze the performance of classification models in artificial intelligence and machine learning. It shows the number of true positives, true negatives, false positives, and false negatives produced by a model. By analyzing these values, developers can calculate important evaluation metrics such as accuracy, precision, recall, and F1 score. Understanding the confusion matrix helps improve AI models by identifying prediction errors and evaluating classification performance more effectively.